Hello everyone, I am Dr. Pallavi Ram. Welcome to my channel Probabilistic Revelations for Engineering. In my previous videos, I have shown you the basics of probability. It starts with an experiment and I have introduced you towards the probability space which has a sample space, then an event space and the probability measure. The probability measure satisfies three different axioms and an extension of axiom number 3 is also seen. Many examples on this probability measure have also been discussed. And in the last video, we have also come across what is the meaning of joint probability. So joint probability stands for any two events A and B, if they belong to the event space, probability of A intersection B. This is called as a joint probability. So in this video, let us explore this joint probability in slight more detail. Now let us say that A and B, which belong to the event space, and these are independent events. So the meaning is the occurrence of event A does not depend on B and vice versa. Occurrence of event B is not governed by event A. So in such a case, we say A and B are independent events. So in this particular case, if we try to figure out what is the joint probability of A intersection B, it can be written as probability of A multiplied by probability of B. So it can be written as the product of two different individual event probabilities. So on this joint probability, now using this extension of axiom 3 and this joint probability, we can solve or we can calculate complicated event probabilities very simply. So let us see one example on that. So assume that we have a basket and the basket has 6 white balls and 5 black balls, and the ball is drawn at random. So we pick one ball at a time, and the ball which is drawn out first time, before we draw the second time, it is replaced back. So we write this as ball drawn out is replaced back. And we are interested in calculating the probability of one event called A. The event stands for encountering a white ball by the third draw. That means first draw, when we make a first draw, if we get a white ball, then that is an element of this A. And in the second draw, first draw, let us say we don't have a white ball, but in the second draw we have a white ball. Then that also is an element of this particular event A. So first draw, let us say we have encountered a white. So then it becomes an element of A. So same way, in second draw, if we get white, means in the first draw we got a black. So first draw we got a black. And in the second draw we got a white. So this element is also a part of this event A. And again, if we have not got this, rather, if we have got in the first draw a black, second draw also one black, and in the third draw if we encounter a white, that is also a part of this event. So this is an event called A, which comprises of these three elements. So we need to find the probability of this event called A. So let us write it like this. So let's say A1 stands for white ball in first draw. And then A2 stands for black in first draw and white in second draw. Same way, A3 black in first, black in second, and white in third. So let's say these are the three events, sub-events, and these three events put together, the total event is event A. So to find out the probability of A, we need to find out the probabilities of each one of these. So that means we can express the event A as A1, union A2 and union A3. Now let us try to find out what is the probability of white in first draw. So that means let us try to find out what is the probability of A1. So A1 stands for white in the first. So if we, before writing this, if we comment upon what are the probabilities in the first draw. So let us say only one draw we are making, that is the first draw. In the first draw, let us say we are interested in finding what is the probability of white ball being drawn and also what is the probability of black ball being drawn. Now, if you observe, the sample space will be having 11 different options. So because there are total of 11 balls, we have 11 different options. So we may get a black and so on 5 times, or we can get a 6 possibilities for white ball. So out of the total 11 fundamental or elementary events, probability of one outcome at a time, that is our elementary event. So that probability, if we write, it will be 1 by 11. So probability of white ball being drawn has been a combination of 6 different elementary events. So hence this probability is 6 by 11. Same way, probability of black ball, it's a combination of 5 different elementary events. So hence its probability is 5 by 11. So this is our first draw's probabilities. Now if you observe, the ball has been drawn out and before we draw the second time, it has been replaced back. So even if we draw the second time also, the experiment remains the same. That means first draw is completely not ruling anything related to second draw. Means second draw is not depending upon the first draw. So hence second draw is independent of first draw. So that means again the sample space in the second draw will remain the same. So we have again 11 fundamental or elementary events, and hence the probability of white ball being drawn is 6 by 11 and probability of black ball being drawn is 5 by 11. So same way, every draw is independent of the previous draw. So they have no dependency. So in such a case, we can say that A1, A2 and A3 are all independent of each other. So no two elements, A1, A2, let us say no two sets, A1 and A2, they don't have anything in common. So hence we can say probability of A can be written as, since these are all mutually exclusive events, we can write this as probability of A1 plus probability of A2 plus probability of A3. So probability of A1, if we see, it is the event called white in the first draw. And event called white in the first draw has a probability of 6 by 11. So this is 6 by 11. Now if we want to write probability of A2, we can observe that this is, PR. So probability of B in first, and so that is intersection white in second. Now black in first draw is an event which belongs to first draw. White in second belongs to second draw. But just now we have seen that first draw and second draw are independent of each other. The meaning is this event and this event are independent of each other. So hence I can write the probability of A2 using this rule. We can write it as probability of A into probability of B, this type. So I can write this as probability of B in first multiplied with probability of white in second, because they have no dependency. So hence the answer will be black probability is 5 by 11 and white probability is 6 by 11. So hence this answer will be equal to 6 by 11 multiplied by 5 by 11. So actually it is 5 by 11 multiplied by 6 by 11. So this is for A2 event. Now same way, if we proceed with calculating the probability of A3, so probability of A3 is written as probability of 3 different sub-events. So B in first, intersection B in second, intersection white in third. So all these 3 events are written as intersections. That means it is again a joint probability of 3 different events. So by extending this rule, we can write this answer as probability of each and every individual event product. So that is probability of B in first, probability of B in second, they are multiplied, again multiplied by probability of white in third. So this answer can be written as, we know probability of drawing a black is 5 by 11. Again, second draw is independent of first draw. So hence again the probability of drawing a black ball will be again 5 by 11 because it is replaced back. The ball which is drawn out is replaced back. So again the sample space, fundamental or elementary events, everything remain the same. So same way, third draw is also independent of second or first. So hence this is again white probability, that is 6 by 11. So now calculating the final answer of total probability of A, we can write this as 6 by 11 plus 6 by 11 into 5 by 11, and this is 5 by 11 multiplied with 5 by 11 again multiplied with 6 by 11. So this is the overall probability of A. So you can see that we have expressed the event A using 3 different events which are independent and they are mutually exclusive. And we have used the joint probability, that is probability of A intersection B is equal to probability of A into probability of B only when they are independent events. This rule along with the mutually exclusive or the independent event rule, that is this axiom number 3 itself. So with the help of this and this, we were able to write the answer of complicated event A probability in terms of these A1, A2, A3, and hence this joint probability definition has come of use when we wrote this sub-event probabilities. So thus an example with the application of joint probability of independent events and extended axiom 3 we have seen as an application here. So thank you very much. If you like this video, please don't forget to subscribe to my channel and please also click the bell icon to receive more updates about this. Thank you once again.